Hi everybody, this is Math 024, Module 1, the third video, the last video, and in this video we are going to be looking at applications of exponents, so when we would use exponents in real life, where we might see them. The first thing we're going to look at is scientific notation. So anytime you have a very large or a very small number, with lots of digits to it, writing it out the whole way, the whole time, is not always feasible or needed, and so sometimes we put it into scientific notation. And a number that's written in scientific notation will always be written in the form of a times 10 to the r power, and r is always going to be an integer greater than 0. An integer, so it's not going to be, you're never going to put 0 there, but you could have, since they say an integer, it could be a positive or a negative number. And a is always going to be a number that is always going to end up being between 1 and 10. So it can't be 1 and it can't be 10. It has to be between 1 and 10. So we're going to look at two things. We're going to convert a number in standard notation to scientific notation. So a large or a very small number into scientific notation. And then we're also going to learn how to take a number that's in scientific notation and write it in standard form. So to convert a number to scientific notation, the first thing you have to do is we need to have that a value between 1 and 10. So you're going to move the decimal point in your number until it is a number between 1 and 10. And that's important. It has to be between 1 and 10. Then you're going to count the number of places you moved that decimal point, because that's going to be your exponent for 10. If you moved to the right, your your r value is negative. And if you move to the left, your r value is going to be positive. And we'll take a look at how to look at that and see what it means. If you have a number that is in scientific notation, you have to determine r. So you have to look at what's the exponent with the 10. Okay? And if that number is a positive number, you're going to move the decimal point to the right. And I always think positive, your number gets bigger. If it's a negative number, you're going to move it to the left. Negative, your number will get smaller. And we're going to take a look at some examples on the next page, so you'll see what I mean. All right, so we're going to start off here, and we are going to put some numbers into scientific notation, and then we're going to take some numbers out of scientific notation. So for a, the first value we have, this is a number that is a very small decimal, and writing it out all the time might be cumbersome, or they just want a better way to look at this number to show that it's very small. So we're going to put it in scientific notation. And again, remember, the first thing we have to do is find a, and we have to make a number between 1 and 10. So what I'm going to do is I'm going to move that decimal point over. I'm going to count as I do it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. If I stop right there, that's going to give me the number 5.37, which is a number between 1 and 10. Okay, if I go further, it would be like 53.7 or 537, which is not between 1 and 10. So you want to stop when you get between 1 and 10. Then you're always going to put your times 10. And we counted when we moved it. Well, we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So we moved that decimal point over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So I just counted it twice. And because we took a smaller number and made it larger, remember, we moved to the right. So when we move to the right, when we're putting a number in a scientific notation, use that negative exponent. So it's going to be negative 10. And that's it. Our number is in scientific notation here. Now, if you look at b, this is a very large number that we want to make and write in scientific notation. So again, we have to start and make our number between 1 and 10. So I'm going to start at the back, because remember, if you don't see a decimal point, it's all the way here in the back. We're going to move it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, if I stop there, is my number between 1 and 10? Not yet. 15, 16. So we moved 16 times and we have 3.215. And you want to write all of the significant digits, which are the digits other than like 0. So, I can stop after the 5 because it's all zeros after that. But we want to make sure that we include any numbers after that decimal point that are not zeros. So we have 3.215 times, and we moved it 16 times, but we moved to the right. We made a larger number smaller, so you're going to use a positive number. So think, if it's bigger than 10, I want you to put a positive exponent when you're putting it into scientific notation. If it's smaller than 1, then you're going to use a negative exponent, if that helps. Now for C, we're going to put this number in standard form. So it's already in scientific notation. So I'm going to write my 1.37, but I want to put it in standard form. And you've got to find that R value. So we look at that exponent. It's a 6. It's a positive number. So think positive, your number is going to get bigger. So that means I have to move my decimal point 6 places. So I'm going to go 6 places to the right. So I'm going to go over 1, 2, 3, 4, 5, 6. And every time that I move it over, if there's no digit there, I'm going to add in zeros. And then, so my number is going to be 137, and then 0, 0, 0, 0. And then you could start from the back, and every 3 values, put in your commas. So we have 1,370,000 there. Now for D, okay, let's see here. We are going to take our number here, 2.4436, and we're going to put it in standard form. Now my R value is a negative 10. Negative, think it's going to go smaller. So we're going to move to the left. So I'm going to start right here, and I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to put my decimal point there. And all of those empty spaces, I'm going to fill in with zeros. So this is a very small number. It is, we got 9 zeros there. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we keep all of our digits, 2, 4, 4, 3, 6. And you might notice, so like we have negative exponents here. Scientific notation is the one time you can keep those negative exponents. Otherwise, we don't like them and we have to get rid of them. But that's how we work with scientific notation. Okay, so now we're going to do some operations with scientific notation. And what they don't say here is they say to multiply, but they really want you to leave your answer in scientific notation. So we're dealing with those very big or very small numbers, and we're going to deal with our but keep it in scientific notation. So remember, multiplication is commutative, meaning you can change around the order of those values. So what I'm going to do is show you how we can make this nice and easy. So we're going to do 1.2 times 3. So I'm going to put the A values together times, and then I'm going to do 10 to the 4th power times 10 to the 15th power. And what we're going to do here is we're going to multiply the 1.2 times 3, because those are our A values. And that's going to give me 3.6. I'm going to keep that times sign, and then I'm going to combine the tens and leave them as a power. So remember, same base, we're multiplying, so we can add those exponents. So it's going to become 10 to the 19th power, because 4 plus 15 is 19. So 3.6 times 10 to the 19th power is my final answer. Now, sometimes when you do this, your A value will not always be a number between 1 and 10, so we will have to modify that a little bit. So if you see that, you have to modify it somewhat. All right, let's look at the next one, where I think you're going to see that same situation I just talked about. So again, I'm going to put the A values together, so 7.2 times 5.4, and then times, we'll put the powers together, 10 to the negative 7th power times 10 to the 17th. Okay, when I do 7.2 times 5.4, I end up with 38.88. And then when I do my tens, -7 plus 17 is going to give me 10 to the 10th power. But if you notice here, this number is not between 1 and 10. So I do have to modify that a little bit. I need to move my decimal point over one place so that it makes it a number that's between 1 and 10. So I moved it over one place. I made a larger number smaller. So remember, when you move to the left, you add a positive number. So I'm going to add a 1 to that 10 because I moved it over one place. So now it's going to become 10 to the 11th power. If I were to move it to the right, then I would be adding negative numbers. But right now, because I'm moving to the left, when I'm working on putting it into scientific notation, I add a positive number. All right, so here we are going to be working with division, and we're going to do the same thing. We're going to kind of do some, I'm just going to kind of draw a line here. We're going to write our answer in scientific notation, but I'm going to deal with the A values first, and because it's division, I'm going to actually take the 6.4 and divide it by 3.2, and that is going to give me the whole number 2. So that's a number between 1 and 10, so we're good there. Times, and then here, remember, we are dividing powers with the same base. So instead of adding those exponents, we are going to subtract them. So we're going to have 2 times 10 to the 15th power here, because 25 minus 10 is 15. And that's our final answer. We're all done. All right, let's take a look at the second one, or D here. All right, again, we're going to take 2 and divide it by 8. And, because you always take the top number, divide it by the bottom number. So I end up with 25 hundredths when I do that. Times, and then here, 10 to the, we're going to do 13 minus 16. So 13 minus 16 is going to give me a -3, which again is okay in scientific notation. But notice, 25 hundredths, that number is not between 1 and 10. So I have to convert it to a number between 1 and 10. So what I need to do is I need to move that decimal point over one place. So it becomes 2.5. Now remember, I moved it from the left to the right while putting it into scientific notation. So that means I have to add a -1. I moved it one place, so I'm going to add a -1 to that. So now it's 2.5 times 10 to the -4th power. And that's our final answer. All right, so now we are looking at some problems where we need to, do what they ask. And the first one says the moon is approximately 2.4 times 10 to the 5th power miles from the Earth. And they want us, that's in scientific notation, so they want us to convert it to standard form. So again, we take that 2.4, that A value, and we have a positive R value. 5 is a positive number. So remember, if we're taking it out of scientific notation and it's a positive value, you're going to move it to the right 5 places. So we're going to go over 1, 2, 3, 4, 5. So I'm going to add in those 4 zeros that I need to. So our answer is going to be 2, 4, 0, 0, 0, 0. And then again, start from the back. Every 3, place a comma. And so the moon is approximately 240,000 miles from Earth. All right. 2, the gross domestic product of the United States was $12,460 billion, or 12,460,000 items, I guess, in 2005. Write this in scientific notation because it's not money, it doesn't have money there. All right, so we got to write it in scientific notation. So we're going to start at that decimal point, which we have. It's back here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I moved it 13 places to get 1.246. And then again, I moved it 13 places, so it would be times 10 to the 13th power. It's a positive number because I took a larger number and made it smaller to put it into scientific notation, so that means we need a positive exponent. Okay, so for our next problem, we have an August 2011 report noted that Facebook has approximately 250 million photos uploaded daily. How many photos in that year, 365 days, were uploaded? So let's take a look. For part A, we want to write 250 million in scientific notation. So the first thing I'm going to do is I want to write 250 million out in standard form. So they just put 250 million, but we need to write it out so we can see how many values are after that 250. Okay, so here's 250 million. And then again, I need to move that decimal point over 1, 2, 3, 4, 5, 6, 7, 8 places. So we're going to have 2.5 times 10 to the 8th power. And then 365, to write it in scientific notation, is pretty easy. It's a smaller number, but we can do it. So again, the decimal point's at the end if you don't see it. So 1, 2. So it's going to be 3.65 times 10 to the 2nd power. And then for C, they want us to multiply those answers together. So we're going to do 2.5 times 10 to the 8th times 3.65 times 10 to the 2nd. Excuse me. And so again, I'm going to reorganize it. I'm going to make it 2.5 times 3.65 times 10 to the 8th times 10 to the 2nd. So 2.5 times 3.65 is going to give me 9.125 times, and then here, add your exponents. So 10 to the 8th times 10 to the 2nd is going to be 10 to the 10th power. And that's it. So those are the number of pictures uploaded yearly on Facebook as of August 2011. I imagine it's a little bit different now. So the next thing we're going to look at is a compounding interest formula. So the formula that's given here, the A equals P times the quantity of 1 plus R divided by N, all raised to the NT power, gives the amount of money in an account after an elapsed amount of time. So if you have a savings account or an investment account that earns interest and it's compounded, this is the formula they use to figure out how much interest you should receive. So A is the amount of money you have after a certain amount of years. P is the principal, so how much money you put into the account. I put $500 in the account, so that's my starting point basically, or whatever amount it is. R is the interest rate, and they're going to give it to you as a percentage, but you're going to want to convert it into a decimal to work with it. N is the number of times compounded per year. So if it's quarterly, it would be 4 times a year. Semi-annually is twice a year. Monthly is 12 times a year. And then T, time for this formula is always going to be in years. So you want to keep it in years. So we are going to use this formula to determine the amount in an account in which someone invests $100. And I want to know how much is in the account after 4 years at 3% compounded monthly. So 100 is going to be my P. It's what I put in. 4 is going to be the T. 3% as a decimal, remember you move it over twice, is 0.03. And that is going to be my rate. And then N, it's compounded monthly, so N is going to equal 12 because there's 12 months in a year. So we're going to start off with A equals 100 times 1 plus my rate is 0.03 divided by 12 raised to the N, so 12 times the time, or 4. Now, this one you have to be careful. If you're going to enter it into your calculator all at once, it's sometimes hard if you don't put it in the right way. So I always recommend doing it in parts. The first thing I want to do is find out what my exponent is. So I know 12 times 4 is 48. So that's the exponent I'm going to use, not the 12 times 4, but the 48. So I multiply that. Now remember, order of operations, you want to do those parentheses first. So I'm going to take the 300th divided by 12 and add 1. And so right now I have this. I have A is equal to 100 times 1.0025, all raised to that 48th power. Now, after parentheses, remember exponents come next. So we're going to take this 1.0025 and raise it to the 48th power because that 48 is attached to this. So I'm going to, on my calculator, raise it to the 48th power. And that is going to give me A is equal to 100 times, and I'm not going to round or cut off any numbers until the very end. So whatever the calculator gives me, I'm going to keep. So I'm going to do 1.127328021. So I wrote everything that it gave me, and then I'm going to times that by 100. And I get A equals 112.7328021. Now we're dealing with money, so we're going to round to the hundredths, which is right here, the 3. So if I look to the neighbor next door, it's a 2, so I'm going to leave it alone. So my final answer is going to be $112.73. So that's how much I will have in my account after 4 years at 3% compounded monthly. Remember, I put in $100 and I have $112.73. So the amount of interest that I gained is $12.73. Okay, so now we're going to do it again. And this time we are compounding quarterly. We are going to invest $2,000. Oops, $2,000 after 20 years at 1.5% compounded quarterly. So remember, my formula is A equals P times 1 plus the rate divided by the number of times compounded raised to the number of times compounded times the number of years. So I am investing $2,000. That's my P. My rate is 1.5%, but remember, 1.5%, if you move that decimal point over 2 places, is going to be 0.015. And always remember, percents to turn them into decimals, you move it 2 places to the left. Think 100% is the highest percentage, that you should have, and that has 2 zeros in it. Let's see here. So I need number of times compounded. If it's quarterly, I always think of 4 quarters and $1. Quarterly is 4 times a year. And then my power is going to be 4 for my N times 20. And again, the first thing I want to do is take that exponent and do that multiplication there. So 4 times 20 is 80. So that's what I'll do. Next, I'm going to do the parentheses first. So I'm going to do my 1,500ths divided by 4 and add 1. And I did division before addition because order of operations says that. So right now I have this. I have 2,000 times 1.00375 raised to the 80th power. So now I'm going to take that 1.00375 and raise it to the 80th power. So now I'm going to have 2,000 times 1.349101617. And then I will do multiplication next because that's what comes next. So I'll times it by 2,000. And when I do that, I get 2698.203235. And we're dealing again with money, so I'm going to round to the hundredths because we always go out 2 decimal places. Because this is a 3, I'm going to leave the 0 alone. So in our account, we're going to have $2,698.20. So that would be, if I invested $2,000 for 20 years at 1.5% compounded quarterly, I'm going to have $2,698.20 at the end of those 20 years. And again, I invested $2,000 of it. So that really means that I made in interest $698.20. Okay, so the last thing that we are going to do is work with some geometry formulas and ones that may have exponents. So we have the volume of a rectangular solid is represented by the formula length times width times height. So you might be familiar with this formula. And the surface area of a rectangular solid is represented by 2 times length times width plus 2 times width times height and 2 times length times height. So the first thing we're going to do is we are given this rectangular solid with the dimensions of length is 5x, width is 2x, and the height is x. So for the volume, they want us to write the expression in terms of x. So remember, volume is length times width times height. So if I write it with my dimensions, I'm going to be multiplying 5x times 2x times x, length times width times height. And they want us to simplify that. So instead of leaving it like this, multiply where we can, combine where we can. So remember, I can do the 2 and the 5, and that's going to give me 10. And then I have x times x times x. Remember, we're multiplying with the same bases, and the exponents on those x's, if we don't see them, are 1s. So it's going to be x to the third power. Okay, now, surface area. Remember, the formula for surface area is 2 times length times width plus 2 times width times height plus 2 times length times height. So when we fill in our formula here, we are going to have 2 times, that's an L, length times width. So it's going to be 5x times 2x plus 2 times width, which is 2x, times height, which is x, plus 2 times the length, which is 5x, times the height, which is x. So now we need to simplify. So in this first expression here, we have 2 times 5 times 2. If I multiply all those numbers together, 2 times 5 is 10, 10 times 2 is 20. And then we have x times x. So remember, those exponents there are 1s. So it's going to be 20x squared plus, and because we have that plus sign there, we're not going to combine it with this one. But let's see here. When we do the multiplication here, we end up with 2 times 2 is 4. X times x is another x squared. Plus 2 times 5 is 10. X times x is x squared. Now, this is taking us back to when we were combining like terms in Math 021 and 020, I believe you did it as well. So when you combine like terms, remember, if they have the same variable and exponent, so they're all x squared terms, add your coefficients together. So 20x squared plus 4x squared plus 10x squared is going to give us 34x squared for the simplified formula in terms of x. So now they want us to use those simplified formulas to find the volume when x equals, in this case, 2 for the first one. So remember, our simplified volume formula for the rectangular solid that we were given, which you can see below, was 10, the volume equals 10x cubed. So remember, we're going to plug in that 2 for x. So we're going to do 10 times 2 to the third power. Remember, 2 to the third power is 2 times 2 times 2. So we're going to end up with 10 times 8, because 2 times 2 times 2 is 8. And that's going to give us 80, and volume is always centimeter or units cubed. So we have centimeters, so it will be centimeters cubed. Now for D, for surface area, remember when we simplified that formula, we came up with the surface area based on our dimensions was equal to 34x squared. So now x is 5 inches. So we're going to do 34 times 5 squared. We know that 5 squared is 5 times 5, or 25. So now we're going to do 34 times 25. And that is going to give us 850 inches squared, because surface area is always square units. So it'll be 850 inches squared for our final answer there. All right, so we are on our last problem for Module 1, Video 3. And this will be the final video for this module, so it's the last part we're going to do. Now we're going to look at a cylinder. And the cylinder, when you have a cylinder, the volume is pi times radius squared times height. And the height of our cylinder, which you can see in the picture, is 7x squared, and the radius is 3x. So they want us to write the volume in an expression simplified in terms of x. So basically what we want to do is we want to take this formula, the pi times radius squared times height, and substitute in the values that we know. So pi, again, we're going to keep our pi symbol. Our radius was 3x, so we have to square that 3x times our height, which was 7x squared. So now what we got to do is we got to simplify all this. So let's distribute our 2 first. So we're going to have pi times 3 squared times x squared times 7x squared. Okay, we know that 3 squared is 9, so we have pi times 9, and then I'm going to move that 7 over, and then x squared times x squared. Add those exponents, because we are multiplying, so x to the 4th power. So our simplified formula is, and we're going to do the 9 times 7 first, 63 pi times x to the 4th power. And typically, again, we put the number first and then like pi in the variable. So next what we're going to do is we're going to approximate the volume to 2 decimal places when x equals 1.5. So we're going to use our formula, and we're going to do 63 times pi, which for pi you can use the pi button on your calculator, or I typically just use the 3.14 unless they tell me different. So that's what we know for our equivalent to pi, times 1.5 to the 4th power. So I'm going to start off, and again, exponents first. So I'm going to do 1.5 to the 4th power first. And that's going to give me 63 times 3.14 times 5.0625. And I'm going to multiply all 3 of those numbers. So I'm going to take that 5.0625, times it by 3.14 and 63. That's going to give me 1001.46375. But our answer says to approximate to 2 decimal places. So we're just going to go out to this 6. Again, because that's a 3, we're going to leave the 6 alone. So our final answer is 1001.46 feet. And it's volume, so cubed. Now, if you use the pi button, your answer, your decimal part here might be off a little bit different. It might be a little bit different, and that's okay. And especially like on my math lab, and when you're doing a test or a quiz for me, like if you use the pi button, or I can see that, we'll know why the decimal point is off a little bit, because when they use the actual pi button, it goes out further in decimal values, so it will add a little bit to your answer. But I hope this video was helpful, and that's it for Module 1.